Hey guys, so just one last thing. I know you guys have been reviewing a lot for your AP exam, but tomorrow you are expected to have an experimental design FRQ. You're going to have to be able to identify the independent, dependent variables, constants, and control. So I just thought I would do an example for you out of your study guide, okay? Because it is imperative that um, we do know how to do this because you're going to have to be able to identify it. Okay, so for this first one, we just have to identify the independent, dependent, control, and constants. Now on your FRQs, if they have you write your own experiment, you also need to be able to say how you're going to collect your data. So how it will be collected, and then also how you would measure whatever it is that you're measuring. So just be aware of that. And also remember that you always want to say that you would repeat your trials in order to test the validity of your hypothesis. So the very last sentence should be like, this test would be repeated 50 times, 75 times, 100 times, something to increase the validity of your experiment, okay? So I'm going to just read through this first one, go over IV, DV, control, and constants, and then I'm going to give it to the universe. It's in your hands after this. So it says Jennifer wanted to determine the LD50 of copper sulfate on brine shrimp. In 2 petri dishes, she put a 10% solution of copper sulfate. In the next 2, she used a 1% solution. In the next 2, a 0.1% solution. And in the next 2, a 0.01% solution. And in the last 2, a 0% solution. She put 10 brine shrimp in each petri dish and examined them at the end of 24 and 48 hours. From this, she was able to determine the approximate concentration at which 50% of the brine shrimp died within 48 hours. So we're identifying our IV, DV, control, and constants. Now, independent variable, the way I always remember it is it's the thing that I change, okay? It's the thing about the experiment that you are manipulating. It is the experimental variable. So if we take a look at this experiment, what Jennifer is manipulating is the concentration of the solution of the copper sulfate. Okay, so the copper sulfate solution is what she is manipulating. Okay, she's trying to see how the brine shrimp react to the concentration of copper sulfate. So our independent variable, the thing that or the thing in this case that Jennifer is manipulating, is going to be the concentration of copper sulfate. Okay. So that is the independent variable. It's the thing that's being manipulated about the experiment, the thing that I change. Okay, it's the experimental variable. The dependent variable is the thing that's being measured. Okay, so the dependent variable will change in response to the independent variable. That's why it is always graphed on the y-axis. So let me put this up here. So independent is always on the x-axis, and then dependent will be on the y. So since the dependent is what we're measuring, in this case is what Jennifer is measuring, Jennifer is measuring how the shrimp respond to the percentage of copper sulfate. So what she's actually measuring is the death of the shrimp. Okay, she's measuring the death of the shrimp in order to get to the LD50. So for our dependent variable, what you're measuring is going to be death of brine shrimp, which is in response to the change in the copper sulfate. Okay, so the death of the brine shrimp is what she's measuring to get the LD50. So she'd have to do a calculation to get to the LD50. That would be like her final analysis. So like her hypothesis would be in relation to what she thinks the LD50 is, or if I increase the concentration of copper sulfate, then more brine shrimp will die. That would be an example of a hypothesis. So IV, again, the thing that I change or I manipulate, so the experimental variable, whatever is changing, okay? If you can identify what is being changed, so what variable is being varied, what is being changed in the experiment, you can identify the independent. The dependent is what is being measured. So look at the experiment. If you have to create your own, think about what you would measure to get your results. That will be your dependent. And then in an example where they give you if they give you an experiment, you have to find what the experimenter is measuring. Okay, so Jennifer is measuring the death of the brine shrimp in response to the change in the copper sulfate. Okay, and this is always graphed on the y. So it's called the dependent variable because the dependent variable changes in response to the independent variable, which is being manipulated. Okay, the amount of brine fish dying, dependent, changes based on the concentration of the copper sulfate, which is the independent. Okay, so the control here is going to be, first of all, controls are important because they give you a baseline of data. You can never do an experiment without a control because without it, your results don't mean anything. Okay, so the control here is going to be the last two. Okay, so it says the last two, she used a 0% solution, meaning that she didn't add copper sulfate. Okay, so it would just be the natural environment of the brine shrimp. So it would just be the Petri dish without copper sulfate. Okay, so brine shrimp aren't typically in a copper sulfate solution. So the control is always the natural environment, okay? They're not exposed to the experimental variable. So your control will always be whatever is not exposed to the experimental variable, which is your independent variable, okay? So in this case, a 0% copper sulfate solution would be our control. We're not exposed to any concentration of copper sulfate, okay? And then the constants, experiments should also always have multiple constants because you only ever want to measure one variable at a time, okay? In this, we're measuring the shrimp's response to copper sulfate solution and copper sulfate solution only. So you can never measure two variables because you'll never be able to tell like where your results come from. So you want to keep everything else the same. So for like constants for this one would be amount of shrimp in each Petri dish. Also, the timing, so like the timing of measurement. So like each Petri dish was measured after 24 and after 48 hours. You didn't have like the first one measured after 24 and the second one measured after 36 because that wouldn't be consistent, okay? Also like it's not specified in here, but if you guys had to give constants you could also use would be like the type of brine shrimp, because it wouldn't change. You would need like the same species or whatever. The amount of water like they're held in, so like the amount of water. And that's an important one because if you have a big tall glass of water that you dump the brine shrimp in and then like a tiny Petri dish of water, that can affect concentration, right? So you want to make sure that that is kept the same. So constants are just things that are kept the same in the experiment to make sure you're only testing one variable. And for here, our one variable is going to be the copper sulfate solution. Okay, so once again, independent variable is a thing that I manipulate. It's the experimental variable. Here it's the copper sulfate because we're manipulating the concentrations. We're changing that from trial to trial, not trial to trial, but from variable to variable, so Petri dish to Petri dish. DV, dependent variable, is the thing you measure. If you can find what you're measuring in the experiment, or if you're creating an experiment, whatever you're going to measure is going to be your dependent variable. Okay, control is the conditions without the experimental variable. So like in this example, no copper sulfate added, and then constants are just things that remain the same. And you can find multiple constants in any experiment. If you guys are asked to list constants, if they don't give you a specified amount they want, I would say list at least 3. Okay? All right. I think that's it. Good luck on your exam. If you guys have any questions at all, please let me know. I have faith in you. If you have any last minute concerns, also let me know as well. But you guys will do just fine.